All right, so this problem is fairly straightforward if we have the formula. You guys have that formula in front of you, or at least some of you do, that the derivative with respect to x of a to the u is what?
A to the u times natural log of a times du dx.
Okay, so if you know that formula, you can just plug it in, basically. Let's say you don't know that, though. You've forgotten that formula. You're taking a test, and you're drawing a blank. So that's gone. What do we do? Any ideas? What do you say, Evan? Yeah, exactly. If we take the natural log of both sides here, we get the natural log of y is equal to the natural log of 3 to the cotangent of x. And why is that useful? Why is the log, introducing the log in this problem, useful to us?
You could use logarithmic properties to move it around.
Yeah, we can use logarithmic properties to rewrite it in a way that's a lot easier to take the derivative of. So we can take that exponent, in this case, the cotangent of x, and put that out front. So then what we have is the natural log of y equals the cotangent of x times the natural log of 3. Now, one important thing that's hard to remember sometimes, but the natural log of 3 is a what? Constant. It's a constant. It's just a number. It would be the same thing as just saying something like 3 times the cotangent of x. And when we take the derivative of that, the derivative is just going to be, in this case, 3 times whatever the derivative of cotangent of x is. So in this case, we're going to have the natural log of 3 times whatever the derivative of cotangent of x is. It's just a number, so we don't have to use the product rule there. We're just going to take the derivative. Let's start, though. Let's just go term by term. What's the derivative of the natural log of y going to be? Yep, so we're going to use implicit differentiation. It's 1 over y times dy dx. And that's going to equal, I'll put the natural log of 3 out front. And then what's the derivative of cotangent of x?
Negative.
Ooh. You guys remember that one?
Yeah.
I take it from your silence that Evan is the only one that does remember it. Maybe 1 or 2 other people. So let's. This is a good example to do this on, since we're kind of doing a workaround here. What if you forget what the derivative of cotangent is? We want to find the derivative of the cotangent of x. Yeah, rewrite it as, and if you forget that cotangent is cosine over sine, then you're kind of out of luck. But rewrite it as cosine of x over the sine of x, and then what do you use here? Quotient rule. So low d high, low d high, minus high d low. Okay, high is cosine of x, d low is cosine of x, all over sine squared of x. Well, that doesn't look like cosecant squared of x. What's going to happen here? You want me to tell you? What's negative sine squared of x minus cosine squared of x? Negative 1, good. So it's negative 1 over sine squared of x, which then is, sorry, I forgot the negative, negative cosecant squared x. Obviously, if you know it, it's going to go a lot faster, but if you don't know it, you can still figure it out if you know the quotient rule and you know those trig identities. In this case, here we're using sine squared plus cosine squared equals 1, right? All right, so we've got this. What do we do now to get dy dx by itself? Multiply by y, so we get y times negative natural log of 3 times cosecant squared of x. And we need to do one more thing. The function itself originally was not implicitly defined. It didn't have any y's mixed with x's, so we need to get rid of the y here by doing what? Substitute, exactly. So we're going to do 3 to the cotangent of x times, and actually I'll put that negative out front, the natural log of 3 times cosecant squared of x. That is exactly what you would have gotten if you had used the substitution with the formula that I gave you. So a would be 3, so we would have the a here and we would have the a here. U would be the cotangent of x, so we would have the cotangent of x here. And the derivative of cotangent of x, which is negative cosecant squared of x, so we would have the negative cosecant squared of x. Okay, it's a little bit more work. Actually, it's quite a bit more work if you have to do that. But if you forget the formula, it's better than not doing it at all, right? Yes?
Can we use the product rule?
No.